All right, so we're on to 4.5, simplifying fractions. So before we get started with this, let me show you something that we've looked at before in previous sections, where we had a number line where in the middle we had 1/2. So we had, on one side we had 0, the other side we had 1, and right in the middle we had 1/2. Right? But we also know that if we were to break this down into, instead of 2 pieces, we have 4 pieces now, right? 1, 2, 3, 4 pieces. Then this would be 1/4. This would be 2/4. This is the same spot that 1/2 was in. So 1/2 and 2/4 are the same thing. And if we broke this down further into 8 pieces, this would be 1/8, 2/8, 3/8, 4/8. So we know that we can break down 1/2, or we can express 1/2 in different ways. We also know that if you multiply any number by 1, it stays the same, right? So if you have 3 and then we multiply by 1, then we still have 3. And the same thing happens with fractions. If we have 1/2 and we multiply by 1, we still have 1/2. Right? So we know that we can do that, and that's fine. It doesn't change the number. So if we can do that, can we also do that? Can we do 1/2 times, let's say, 2/2? 2/2 is 1, right? This is the same thing. We're still going to get 1/2 at the end, but we can express it differently. So 1 times 2 would be 2, and 2 times 2 would be 4. We could do that again if we wanted to. 2 times 2, because we're not actually changing the value. It's still the value of 1/2, but just expressed differently. So now 2 times 2 is 4. 4 times 2 is 8, and so on. That's what we have right here. Okay, so if we can go that direction, then we should be able to go the other direction too, to simplify the fraction, to get the smallest numbers that we can. And we can do that by finding common factors. And you know, for this one right here, we have both even numbers, so you know that it's going to have a common divisor of 2. We also know, because we multiply by 2 twice, it's going to also have a common divisor of 4. Let's just go ahead and do 2 at a time. So if we were to break this down, say 4/8 is the same thing as, say, 2 times 2 over 4 times 2. Right? So 2 times 2 would be 4. 4 times 2 would be 8. Okay, so we just kind of broke that down. And we can break these fractions up if we want to. So that'd be 2/4 times 2/2. Well, we know 2/2 is just 1, so that ends up getting canceled out, and we're left with 2/4, and we can do it again. So 2/4, we can break down to 2 times, or 1 times 2, and 2 times 2. And the 2's cancel out, and we're left with 1/2. So that's how we're going to go about simplifying these fractions, doing things like that. So let's get started with problem 4.27. So let's write 12/30 in simplest form. So a couple of different ways that we can do this. One thing, as you get more practice with this, you're going to start recognizing multiples if you don't already. So when you see the number 30, you should know, oh, that's a multiple of 6. If you see the number 27, you might think, oh, that's a multiple of 3. You're going to recognize numbers as you see them more and more. 21, if you see a 21, you should think 7, multiple of 7, things like that. Some larger numbers, 932 or something like that, you might not know what that's a multiple of just by just glancing at it. But a lot of numbers that are, especially 2-digit numbers, you should start recognizing if they are common multiples. So, like 36 and things like that. So anyways, these are both even numbers. So we could just break this down, dividing by 2 at a time. You might also recognize that these both have a common divisor of 6. So let's go ahead and try that. So let's do 12 is going to be the same thing as 2 times 6. 2 times 6. And 30 is the same thing as 5 times 6. Okay, and then so that becomes 2/5 times 6/6. we don't really need this step here. I'm just showing it to break down what it is we're actually doing. So then the 6 over 6 cancels out. That's just 1. And then we're left with 2 over 5. 2 over 5 are both primes, so you know that that's going to be in its simplest form. And go ahead and check out this video. Link in the description. Okay, one of the properties of division, it was canceling a common factor. So we saw that if we have AC over or divided by BC, we could cancel out these C's and we're left with A over B. So use fraction multiplication to explain why cancel common factor property works. Okay, well, kind of showed that in the last slide. So, and sort of just showed it right here. Let me just back up a little bit. So we know that the way that fraction multiplication works, so we had A over B, and we had another fraction, let's just say M over N. Then we know how fraction multiplication works now. We just multiply across. So this would be AM over BN. That's how we multiply fractions. So if that's how we multiply fractions, we could sort of undo that or write it a different way. This is the same thing as saying A times C over B times C. Nope, that's not a very good looking C. C. And then we can break apart the fractions just like it's written here. And that could be A over B times C over C. And then that's when we can cancel this fraction out, because that's going to be equal to 1. And then we're left with A over B. Okay, so write 225 over 540. So like I mentioned a couple slides ago, you might instantly recognize a number as a multiple of some other number, and sometimes you won't. But you can use your divisibility test a lot and know what a lot of these numbers are divisible by. If you see an even number, for example, you know that that's divisible by 2. In this case, you know that these are both going to be divisible by 5. One ends in a 5, one ends in a 0. So 5 will work for both of these. So let's see, we could do 45. If you don't know what this is, you could just divide. So 225 divided by 5. So that's going to go in 40 times, because 20 is close to that. So 20 and add a 0. All right, and then we're left with 25, and then 5 more. So that's 45. All right, so we have 45 times 5 in the numerator and denominator. So 540. Let's see, that would be 10 and so 108, I'm guessing. Let's see, 540 divided by 5. All right, so I can go in 100 times to be 500. We're left with 40. Yep, and then that's another 8. So 108 times 5. Okay, 5's cancel out, and we're left with 45 over 108. Okay, is this in the simplest form? Well, if we use our 4's divisibility test and look at the last 2 digits, is that a multiple of 4? It is, so it's divisible by 4, but the top's not. Top's divisible by 5, but the bottom's not. How about 9? Remember our test for 9? Add up the digits. 4 plus 5 is 9. Yep, that's a multiple. 1 plus 8 is 9. That should be a multiple also. Okay, so 45, that should be 5 times 9. And 108, let's see, we know 9 times 11 would be 99. So that should be 9 times 12. So let's do 12 times 9. And we have 5 twelfths. And 5 is a prime, and 12 is not divisible by 5. So that is the simplest form there. So that's one way to do it. Another way to do it is our prime factorization. So if we broke 225 down to, so 225, we know it would be 45 and 5, and 9 and 5. So that would be, so 225 over 540 would be, and then 9 can break down to 3 squared times 3. All right, so it would be 3 squared times 5 squared. And then 540 would be 10 and 54. This would be 2 times 5. 54 would be, let's see, 2 times 27. And I think 27 is a prime. No, it's not. 3 times 9 and 3 times 3. All right, so we have 2 squared times 3 cubed times 5. Okay, so what can we cancel out here? Well, we have 2 3s and a 5, or 2 3s, 2 5s, and this has only 1 5, but has enough 3s. So let's go ahead and see if we can break this down. So I'm going to change this a little bit to say 5 times 3 squared times 5. Right, does that make sense? So we're just pulling out a 5 from here to be a 3 squared times 5, and I'll show you why I'm doing that. So here I'm going to have, let's see, 2 squared times 3 times 3 squared times 5. Okay, so I took 2 of the 3's out, and I took the 5. So now we can see that these will cancel out, and we're left with 5 over 2 squared times 3. 2 squared is 4 times 3 is 12. That's 5 over 12. That's another way to do it. And another video right here. Check out. All right, compute each of the following in simplest forms. All right, so this becomes a lot easier if we first simplify these fractions before we multiply. So let's go ahead and do that. So 6 over 8, let's see, so we can cut it in half. It would be 3 over 4, and I think that's simplest form. So let's do that. So 6 over 8 is the same thing as 3 times 2, and I'm still adding in these extra steps that you won't have to do every time, but just wanted to keep showing what we're doing. And then we can cancel out our 2's, so it's going to be 3 over 4. How about 12 over 8? So we cut those in half. It's going to be 6 over 4. We can cut that in half again. So we had 6 over 4, cut that in half again. It's going to be 3 over 2 times 3 over 2. Okay, so now we can multiply across. Now we have 9 over 8. And it looks like that's already in simplest form, so that's good. Okay, so how about this one here? 24 over 32. So remember, keep it negative, so negative. These are both multiples of 8. I recognize that. 32 is a multiple of 8. 24 is a multiple of 8. So I know 8 times 3 is 24. And 8 times 4 is 32. Okay. How about 36 over 45? Well, I know 6 is a multiple of 36, or 36 is a multiple of 6, but not of 45. Let's see, what else? 5 is a multiple. 45 is a multiple of 5, but not 36. So what else? How about 9? Yeah, they both add up to 9. So 9 times 4. This is going to be negative also. 9 times 4 and 9 times 5. Okay. So we know it's going to be a negative times a negative, so we know there's going to be a positive. So let's just go ahead and drop these negative signs. All right, so then we are going to have 3 times 4 over 4 times 5. Well, we know we can take some shortcuts here. We can rearrange if we wanted to. We don't have to, but let's go ahead just to show that. Let's say 3 times 4 over 5 times 4. And now we know we can cancel that. And it's going to be 3 over 5. All right, we could have just canceled from right here also. Okay, cool. So next one. What multiples do we have? So 27 is going to be 3 times 9. 40 is not a multiple of 3 or 9. I'm not really seeing a way to simplify this one, unfortunately. 21 is a multiple of 7, but I don't think 160 is a multiple of 7. Well, might be in a bind here. All right, let's see what we can do. So first of all, we know our final answer is going to be negative. We have a negative times a positive. So let's remember to include a negative sign in here somewhere. And let's go ahead and write 40 times 21 over 27 times 160. Okay, well, actually, when I write it like this, some things sort of stand out. This ends in a 0, that ends in a 0. So I wonder if we switch these around. Let's say 40 times 21 over 160 times 27. Okay, and then we have 40 over 160 times 21 over 27. So 40 times 60, well, that's going to be 1 over 4, right? Divide both by 10, 4 over 16, and then divide both by 4. So we have 1 over 4 times, well, 21 and 27, well, those are both multiples of 3. 3 times 7 is 21, and 3 times 9 is 27. Okay, well, these are a lot easier numbers to be multiplying instead of these big numbers. Also, we got to remember a negative sign. So look back at the original problem, remember that this is going to be negative. So carry a negative through. We know this is going to be negative. So 7 times 1 is 7. And 4 times 9 would be 36. And looks like that's in simplest form already. 7 is a prime, and 36 is not a multiple of 7. All right. So 34 over 33. How do you divide fractions? We multiply the reciprocal. What's the reciprocal of 51/44? That's 44 over 51. Okay, well, I see that might be easier to work with. Let's go ahead and skip a step here. Let's do 44 over 33 times 34 over 51. All right, well, these are multiples of 11, so that's going to end up being 4 over 3 times, let's see. Not sure about 34 over 51, though. Let's see, so 5 plus 1 is 6, so it's not, okay, so that is a multiple of 3. 3 plus 4, that's not a multiple of 3, though. So, yeah, I'm not sure if this one could be broken down at all. So you could just go ahead and multiply these bigger numbers. If you can't find any multiples, there actually is a common factor of 17. So it would end up being 2, because 2 times 17 is 34, and 3 times 17 is 51. That's kind of hard to find. If you don't find that and you just end up multiplying the bigger numbers, that's fine. But it's going to end up being 8 over 9. I'm just looking to see if there's any other ways to do this here. Yep, okay. Okay, Okay, what fraction of 96 is 64? Okay, so another one where it might be hard to know where to start with this. So what fraction, that's not 2. What fraction of 96, of means times, of 96 is 64? So we'll just rewrite this word problem into an equation, make it a little bit easier to work with. So what times 96 is 64? That's the same thing as saying 64 divided by 96 is what? So 64 divided by 96 would be our answer. So let's see, they're both even numbers, so we can say it's going to be 32 over 96 would be 48, it looks like. 48, those are even numbers. That's going to be 16 over 24, and that's going to be 8 over 12, and finally not finally, keep going, and 2/3. Looks like that's our answer. So you can do it like that. You can just keep dividing by 2, or you can see if you can find the highest common factor if you know what it is. So if you know that both numbers are divisible by 8, for example, then you can divide both by 8. But if you don't know off the top of your head, just cutting in half over and over again is a fine way to do it also. Oh yeah, so if you want to check our work, so remember the original problem here is what times 96 is 64. So if we'd say 2/3 of 96, we should get 64, do we? So this would be 2 times 96 over 3, which would be the same thing as saying 2 times 96 over 3. 96 divided by 3 would be 32, so 2 times 32, and that is 64. That looks good. Okay, so let's go ahead and simplify these. All right, these are already broken out into the prime factorization, which makes it a little bit easier because we know we can cancel out 2 of these 5s, right? So cancel that out. Cancel out 2 of these, so this is going to go to 5 to the 1. So this is going to end up being 2 over 3 times 5, or 2 times 15. All right, so same with this one right here. So those cancel out. This goes 7 to the 1. We have 2 over 3 times 7 equals 2 over 21. Nice and easy. All right, how about this one though? We can cancel out 2 of these x's. This would be x to the 1. So we'll have 2 over 3x. Can't simplify that anymore, so that's our answer. All right, if C and D are not 0, let's simplify this. All right, so what can we do here? We can, first let's simplify our integers. So I can see a common factor of 4. So this would be 10 over 4. That can actually simplify more to be 5 over 2. Okay, how about our c's? So cancel out 3 c's, and so that becomes 2. So we have c squared down here. How about our d's? We can cancel out one of these d's here. So here we have 5d. On the bottom we have 2c squared. It looks like that is simplified. And make sure that that's right. 5d over 2c squared. Yep. Oh, and that's it. So hopefully that wasn't too bad. I know that's probably a little bit harder than the last few sections, but still hopefully not that bad. It kind of just brings everything together. Now that we know our common divisors and multiples and everything that we've learned about fractions so far, hopefully this wasn't too hard to understand. There's some shortcuts to be made, and I know it's like some of the shortcuts might be new to you, but once you get a lot of practice, it makes simplifying fractions much easier, and then it makes multiplying fractions easier if you can do a lot of canceling out. So we're doing a lot of that going into algebra. So getting a good handle on doing that to make problems as easy as possible is a really good habit to have.